Hello students, today I'm going to solve the NCERT exercises questions of the chapter Light. We all know that your board exams are coming, and if no one has told you, let me tell you, your NCERT exercises are very important. You need to solve it. You need to solve it correctly, and while solving you should be knowing the concept which we are using to solve those questions. Okay, so let us begin. I'll be solving, and I'll not just be solving, I'll keep on explaining you the concept behind every answer. Okay, so if you face any problem understanding, or if you have any question, you can mention it in the comment section. Now let us not waste time and begin with our solution. So our first question is, which of the following materials cannot be used to make a lens? Students, do you know the property of the material needed to make a lens? That light should pass through them so that refraction can take place, right? So water, can light pass through water? Yes. Can light pass through glass? Yes. Can light pass through plastic? Yes, if it is transparent. Can light pass through clay? No. So can we make a lens using clay? No. So we cannot make a lens using clay. So the correct answer for this is clay. Now going to question number 2. The image formed by a concave mirror is observed to be virtual. Now concave mirror, when we talk about concave mirror, how does it look like? This is the concave mirror, right? Polished outside, and reflection takes place from the inner surface. Now if I'm sure you have completed your syllabus by now, so in a concave mirror we know that we can get both real and virtual images. We can get both real and virtual images. In order to get a virtual, erect, and an image which is larger than the object, we need to place that object between the pole and the principal focus of the mirror. That is somewhat here, between the focus and the pole. All right, then only we are going to get a virtual, erect, and an object which is larger than the object. That is magnified image of the object. So the correct answer will be D, between the pole of the mirror and its principal focus. If you have any problem, just go to the ray diagram and see what kind of image you are getting when the object is placed between the focus and the pole of the mirror. Okay, now let us come to question number 3. Where should an object be placed in front of a convex lens? Now, what is a convex lens? How does a convex lens look like? This is a convex lens. Okay. Now we have to get a real image of the size of the object. So we have seen at different positions when we place an object, what happens to the size of the image, right? We have already studied that. That is in our syllabus. Now we want an image which is real, and we want an image which is of the same size as the object. So to get an image which is of the same size of the object, we have to place it where? At the center of curvature. Okay, so at the center of curvature means we know that the center of curvature is twice of focal length, right? So therefore the correct answer is B, at twice the focal length. Okay, now let us come to question number 4. A spherical mirror and a thin spherical lens have each focal length minus 15 centimeter and are likely to be. Now children, as per the sign convention, we know that the focal length is negative for a concave mirror and a concave lens, right? We all know this. So the correct answer will be 4A. Both will be concave. If you don't know this sign convention, please mention in the comment section. I will try to make a video explaining the sign convention of mirror and lens. For now, remember, for concave mirror and lens, the focal length is negative. Okay? Or just let me explain you in short. See, this is your concave mirror. Where does the focal length of the focus of the concave mirror lies somewhere on the LHS. Okay, so this is your principal axis. Somewhere here is your focus, and this is your focal length, right? So this will be negative. Same way in case of concave lens. This is your concave lens. Your primary focus, where does it lies? On the LHS, somewhere over here. So this is your focal length, which will be negative. Okay, so answer will be 4A. Now let us go to the next question. Number 5. No matter how far you stand from a mirror, your image appears erect. The mirror is likely to be. Now children, we get an erect image in two cases. Either if you're standing in front of a plane mirror, or in case of a convex mirror. In plane mirror, your images will be always erect and of the same size as the object. Whereas in convex mirror, what will happen? Your image will be virtual, erect, and smaller than the size of the object. So the correct answer is 5D. Now number 6. Which of the following lenses would you prefer to use while reading small letters found in a dictionary? Now, in order to read small letters in a dictionary, we want the image to be magnified. So to get a magnified image, what do we need to use? We always need to use a lens which gives us a magnified image. So which lens gives us a magnified image? A convex lens gives us a magnified image. Now there are two options: convex lens of focal length 50 centimeter and convex lens of focal length 5 centimeter. We are going to choose the convex lens of focal length 5 centimeter. As shorter the focal length, bigger will be the image formed. Okay, so the correct answer is 6C. Now going to number 7. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. So what should be the range of the distance of the object from the mirror? We need to find the object distance. We need to find the nature of the image, and is the image larger or smaller, size of the image, and we also have to draw a ray diagram. So for that I'll be needing a lot of space. So let us come here. So over here I was drawing that image. I will redraw it for you. So let me erase this and redraw it properly. This won't do. I was taking a class actually, online class, for which I drew this image. So let us draw it again. So first I'll be drawing a concave mirror like this. Children, make sure you use your compass, ruler, scales. Okay. Then I'll be drawing the principal axis. Okay. After that, I'll be mentioning where the center of curvature, focus, everything lies. So let us mark. This is the pole. Please make sure you take the correct measurements. I'm just drawing it random. This is the focus. Double the focus is center of curvature. Okay. Now, what kind of image do you need? We need an image which is erect. Okay, so to get an erect image, where do we need to place the object? Between the focal length and the pole. So I'll place my object somewhere here. This is my object. Now I will take light rays passing through this. So I'll take two light rays, one which is parallel to the principal axis. So the one which is parallel to the principal axis, it is going to pass through the focus after refraction. Okay, children, make sure, see, and mine is not appropriate. It should pass through the focal point exactly. Okay, like this. And another ray I can take maybe passing through the pole. Okay, you can also take one passing through the center of curvature. So let us take that one passing through the center of curvature like this. So the one that is passing through the center of curvature will return back using the same path, right? So if it is going to return back using the same path, it's going to go like this. Okay. Are they going to meet anywhere? No. So what are we going to do? We are going to produce them backwards like this. So if we produce them backward, what do we get? We get an image which is erect like this. Okay. So let us write the answers. So this is your ray diagram. Make sure you mark everything correctly. If you have trouble understanding the ray diagram, please mention it in the correct comment section so that I can give you a class on the ray diagram. Okay. So a concave mirror gives an erect image when an object is placed between the pole and the principal focus. So this is your first answer. Hence, to obtain an erect image of an object from a concave mirror of focal length 15 centimeter, the object must be placed anywhere between pole and focus. Okay. The image formed will be virtual. As you can see, we have produced it backward. So the image is not real. It's a virtual image. Then it is erect, as you all can see, and it is also magnified in nature. That is, it is bigger than the size of the object. Okay, I hope you got the answers of all your questions. Now let us go back to the next question. So we have done question number 7. We are going to question number 8. Question number 8 says, name the type of the mirror used in the following situations. Number 1, headlights of a car. So in headlights of a car, children, remember we use concave mirror. Concave mirror. All right. So why do we use concave mirror? You say, ma'am, you'll be explaining the answers also. Okay. So remember, we use concave mirrors because it can produce powerful parallel beam of light when the light source is placed at their principal focus. Okay. So that is why we need those parallel powerful beams of light so that we can see the objects ahead of us. That is why headlights of a car has concave mirror. Now, number B, side or rear view mirror of a vehicle. So every vehicle has a side and a rear view mirror. Which mirror is there? It's a convex mirror. Now again, why are we using convex mirror? Because it gives us a virtual, erect and diminished image of the object which is placed in front of it. So now if you get virtual, erect and diminished image, you get a wide view of what is behind you. So the driver needs to see most of the traffic which is behind him or her. Okay, so for that we are using convex mirror. It gives us a wide view, wide field view. Okay, as the images which are formed are virtual, erect and diminished. Now coming to question number C, solar furnace. In solar furnace again we use concave mirrors. Why we use concave mirrors? Because concave mirrors are convergent mirrors. They are used to construct solar furnaces because they converge the light that is incident on them at a single point, which is called focus. Hence, they can be used to produce a large amount of heat at that point. Okay, so if you see the ray diagram of a concave mirror, like this is the concave mirror, right? Let me draw the principal axis. So if parallel rays are incident on a concave mirror, all the lights converge at a point which is called the focus. Okay, so over here there will be a lot of heat. Same way, if anyone asks you another question, suppose there is a part which is D. In case of magnifying glass, So in magnifying glass, we are going to use convex lens. Why? Because convex lens is convergent in nature, just like your concave mirrors. Okay, is it clear to all of you? Now let us go to question number 9. One half of a convex lens is covered with a black paper. Will this lens produce complete image of object? You have to verify your answer experimentally and explain your observation. Now children, convex lens will form complete image of an object even if its one half is covered with black paper. Okay, to understand that I will have to explain you two cases. Let us see that. Okay, let me have another page. Yes. So over here, I'll be showing you two cases. Case 1. For case 1, I'll be drawing a lens. Pardon me for poor drawing. Actually, after a long time, I'm doing it on a pen tab. That is why. Now let us cover first half of it with black paper. Okay, so let me cover it like this. Suppose this part is covered, shaded. Okay, now let us take, also please make sure you give all the names, like you have, this is your optical center, first focus, center of curvature, second focus, 2f2. Okay, now let us see if the object is here. What happens? We are going to take two rays of light passing from here. So if we take two rays, suppose if I'm taking one ray passing through the optical center, so it will be like this. The ray that passes through optical center passes through the optical center like this. So yeah, okay. And another one we can take from the focus. So if we take a light which is passing through the focus like this, so one that passed through the focus, what happens to that? It goes parallelly. Okay, so the image is formed beyond 2f2 here. All right, and full image is formed just like the object was A, B. We have the image also A and B. All right, clear? It's just inverted in nature. So you get a complete image if the first half is covered. In the same way, if you cover the next half also, you are going to get a complete image of the object. That will be our case 2. I hope you have understood. So I'm not drawing it again. Okay. So in that case also, similarly, you are going to get a complete image. Okay. So let us go back to our question. What is your answer? Yes, it will produce a complete image. Verify your answers experimentally. Just show the two cases and explain it. All right. Now, let us go to question number 10. An object, an object 5 centimeter in length is held 25 centimeter away from a converging lens of focal length 10 centimeter. So all the data are given to us. Let us do the ray diagram. We need space for that. So yes, so what is given to us? The object distance is given to us. How much is the object distance? Minus 25 centimeter. Height of the object is given to us. How much is the height of the object? 5 centimeter. Why have we taken negative? Because the object is always in the LHS. Okay. Remember, I hope you all know the sign convention by now. What is the focal length? The focal length is 10 centimeter plus 10 centimeter, as this is a converging lens. Okay. Now, according to the formula, 1 by f is equals to 1 by v minus 1 by u. What we need to find out? 1 by v, the image. So 1 by v is 1 by f plus 1 by u. 1 by f is how much? 10. U is negative, so this becomes minus 1 by 25. Now, if we solve it, we are going to get 15 by 250. Please check your solutions. So, we need to find V. V will be 250 by 15. If you solve it, you're going to get 16.66 centimeter. Now, you see that the object has a sign convention which is positive. Okay, so the positive value of V shows that the image is formed is on the other side of the lens. All right, now let us come to magnification. So magnification is how much? Magnification is minus image distance by object distance. Now image distance, we know what is the image distance. It is 16.66. And what is the object distance? 25. Okay, so what are we going to get? Minus 0.66. So this is the magnification, and the negative sign shows that the image is real in nature. So the image form is real and the image formed is behind the lens. Okay, two things we came to know about the image. Now let us see what is the size of the image. So to know the size of the image, what do we know? We know there's a formula of magnification which is minus height of the image by height of the object. Therefore, height of the image is equals to magnification into height of the object. Okay, so magnification we just got minus 0.66 into height of the object is 5. So if you do this, what do we get? Minus 3.3 centimeter. All right, write all your units properly and carefully. So the negative value of the image height indicates that the image formed is inverted. All right, so we got the position, we got the size, and we got the nature of the image. What is the position of the image? It is behind the lens. What is the nature of the image? It is real. And what is the size of the image? It is inverted in nature. Okay, so we got everything over here. Now let us go to question number 11. Question number 11 says, question number 11 says, a concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. How far is the object from the lens? Draw a ray diagram. So focal length is given to you, and what is given to you? Image distance is given to you. Okay, an image 10 centimeter from the lens. So you have to find the object distance u, and you also have to draw a ray diagram. So let us do that. Okay, so let us first write down what is all given to us. The focal length is how much? 15 centimeter, right? 15 centimeter. And it's a convex mirror. So convex mirror has a positive focal length. So plus 15. The object distance, is it given to you? An object is placed 10 centimeter. Sorry, an object is placed. Object distance we need to know. Image is given to you. What is the image? It is 10 centimeter. Minus 10 centimeter. Okay. Now focal length is negative because over here I just didn't see. It's a concave lens. Okay. So it is negative. My mistake. Just minus 15 for concave. Remember, for concave, focal length is negative. For convex, focal length is positive. All right, now let us do the question with the formula 1 by V minus 1 by U is equals to 1 by F. So what do we need to find out? U. So we'll make U the subjective formula. So 1 by U is equals to 1 by V minus 1 by F. So if you put it, it will be minus 10 minus the focal length is already negative. So what are we going to get? Minus 1 by 10 plus 1 by 15. Negative, negative, positive. All right. So if you solve this, you're going to get minus 5 by 150. Okay. So U will be minus 30 centimeter. So you got your object distance. The negative value of U indicates that the object is placed 30 centimeter in front of the lens. Okay. So we can draw a ray diagram now. So we have a concave lens. Draw a concave lens. Like this, children, you make sure you use proper measurements. I'm just drawing it like that. Okay. We have a principal axis. Now let us mark all our points. This is my, don't make such thick lens, okay? Make a thin lens, please. Okay, this is the focal length f1. Then we have the 2f1. We have the f2. And then we have the 2f2. I hope you all know the making ray diagram by now. Now my object, where is my object? It's 30 centimeter in front of the lens. Okay, and focal length is 15 centimeter. That means object is double the focal length. So if it is at the double the focal length, that means it is at 2f1. So my object right now is where? Here on 2f2. Okay, from here we are going to take two rays. Let us take two rays. One that is parallel to the principal axis, the ray which is parallel to the principal axis, it will pass through the focus. So in this case, it will appear to pass like this, since it's a divergent lens. Okay, and another one we will take it from the optical center. So the one that passes through the optical center goes like that. So my image formed is over here. All right, so this is my image. You can see this is my image. Clear? So this is the ray diagram. I hope you all can do this. Now let us move on to the next question. Question number, we just did question number 11, right? Now we'll do question number 12. An object is placed at a distance 10 centimeter from a convex mirror this time. So your object distance is given to you, focal length is given to you. You have to find the position and the nature of the image. So how are we going to do it? Let us write down the datas. F is equals to plus 15 centimeter. U is equals to minus 10 centimeter. Minus 10 centimeter. According to the formula of the mirror formula, 1 by V minus 1 by U is equals to 1 by F. All right. So 1 by V is equals to 1 by F minus 1 by U. Okay. So 1 by 15 plus 1 by 10. Negative, negative. This becomes positive. So you get the answer 25 by 150, which is V is equals to 6 centimeter. Why? Because 150 by 25. Okay. The positive value of V indicates that the image is formed behind the mirror, not in front of the mirror. So now let us find out the magnification. So where is the position of the image? Behind the mirror. The mirror. Now let us find the magnification. The magnification is, again, what is the formula? Image distance minus image distance by object distance minus V by U. So if we place the values, minus 6 by minus 10. So you will get plus 0.6. Okay, so this is your magnification. The positive value of magnification indicates that the image formed is virtual and erect. Okay, so virtual images are always erect. So erect. Okay, so you got the nature and position of the image formed. We have done question number 12 also. Number 13. The magnification produced by a plane mirror is +1. What does this mean? Now, whenever the magnification is +1, it shows that the image formed is of the same size as that of the object. So, in case of a mirror, it is possible from by the help of a plane mirror. So, the positive sign shows that the image formed is virtual and erect. Okay, is it clear to all of you? It's same size, so it is by a plane mirror, so it means this. Clear? Now, number 14. Number 13 done. Number 14. An object 5 centimeter in length is placed at a distance 20 centimeter in place in front of a convex mirror of radius of curvature 30 centimeter. Find the position of the image, its nature and size. Again, you have to solve it using the same formula. So I have already done so many questions using the formula, the mirror formula. So I'm sure you'll be able to do it. In case if you're not able to do it, please let me know in the comment section. I'll solve it. Okay. So now let us go to question number 15. Again, similar question. We have to solve it. We have to find the size and the nature of the image like we have done in the previous questions. Number 16. Find the focal length of a lens. Okay, this we haven't done, right? So let us do that. What we have to do? We have to find the focal length. What is the formula for focal length? Power is equals to 1 by f, and the unit of f should be in meters. So f in meters. All right. So given to us is the power is minus 2.0 diopter. The unit of power is diopter. We write it with a capital D. Okay. So focal length will be 1 by minus 2, which is 0.5 meters. All right. So clearly, since it is negative focal length means what? It's a concave lens. Concave lens and concave mirrors have negative focal length. I'm repeating it again. Now let us go to question number 17, which is the last question of your exercise. A doctor has prescribed a corrective lens of power. Again, power is given to you over here, and you have to find the focal length of the lens. Come on, let's do it. Last question. Question number 17. Okay, what is the formula? Please, students, make sure in your board examination you write down the formula every time you do a numerical. Don't skip writing the formula thinking that the examiner must be knowing the formula. The examiner wants to see if you know the formula. So 1.5 diopter is given to you. You have to find the focal length, which is 1 by 1.5. You solve this. This is 5, okay? You get it? 0.66 meter. So a convex lens again has a positive focal length. Like in this, we got negative focal length, so it is concave lens. But here we are getting positive focal length. That means this is what kind of lens? This is convex lens, which is a converging lens. Okay, so that was the solution of all the 17 questions from your exercise. I hope you understood everything. If you have any problem, you can mention it in the comment section. Thank you, children.